Now we are going to look at maximum and minimum value of functions of two variables. Maximum and minimum. Minimum of functions. All right. Now let z equal f of xy here be a function of two variables, x and y. Z is said to have maximum or minimum, to be maximum, all right, to be maximum or minimum at point AB if one partial z partial x equal partial z partial y, which is equal 0. Then number two condition is that partial square z partial x square times partial square z partial y square minus partial square z partial x partial y square greater than 0. Now see, if this number 2 is greater than 0, it means there is maximum or minimum. So we then test for maximum. For maximum. Now, 1, if partial z partial x equal partial z partial y, which is equal 0, number 2, and partial square z partial x square times partial square z partial y square minus partial square z partial x partial y square is greater than 0, and partial square z partial x square partial square z partial y square are both negative at AB, then z equal f of xy is maximum. It's maximum. All right. We also look at minimum. Now, if partial z partial x equal partial z partial y, which is equal 0 at the point AB, and again partial square z partial x square times partial square z partial y square minus partial square z partial x partial y square is greater than 0, and partial square z partial x square partial square z partial y square are both positive. That is, both have positive value, positive at AB, then z f of xy is minimum. You know, here they have, yes, they have positive there, so they have, here is minimum. will be minimum at that point. All right, so to apply this condition, we want to take one example and demonstrate how we can find the maximum and minimum point of function of two variables. Okay, so let's look at this example. Determine the maximum and minimum of the function z equal x cubed plus y squared minus 63 times x plus y plus 12xy. Right, so the solution is in this form. I have that z equal x cubed plus y squared minus 63x plus y plus 12xy. Now, partial z partial x, look at that, partial z partial x will give me 3x squared minus 63 plus 12y. All right, partial z partial y will give me, okay, this is x cubed, is x cubed, it2 is x cubed, so we have 3y squared minus 63, yes, plus 12x. So at stationary points, partial z partial x will be equal partial z partial y, which is 0. So that means this equation become, if here is 0, this equation become 3x squared minus 63 plus 12y, and then this one also become 3y squared minus 63 plus 12x. Okay, equals 0, equals 0. So this gives us 1, this is 2. Okay, now if we divide this, divide it through, we can divide this by 3. Yes, we also divide this. We will have something like this: x squared plus 4y minus 21 equals 0. This one will give us y squared plus 4x minus 21 equals 0. All right, so let me call this equation 3 and call this 4. Now, subtracting 4 from 3. If I subtract equation 4 from 3, I will have something like this: x squared minus y squared. Then we'll have minus 4x minus y. You know why? Because this time this will give me back this 4 plus 4y, and this is giving me minus. You know, I'm minusing this way, so it will be equal 0, which I can also write it as x minus y, then x plus y minus 4 equals 0. If you multiply these two, you'll get back everything here. So that is what it means, which implies again that x minus y equals 0, or x plus y minus 4 equals 0. We'll take note of here because we'll be using that place. So now from here, now we see that from here x minus y equals 0 implies that x equal y. So I can now substitute x equal y into 3, x equal y into this 3. So we then have x squared plus 4x minus 21 equals 0. See that? So this is a quadratic, which 7 minus 3 give me 4 by factorization. then 7 times minus 3 give me minus 21. So that gives me that x plus 7, x minus 3 equals 0, meaning that x equal minus 7 or x equal 3. These are points, x equal minus 7, x equal 3. So when x equal minus 7, so if you put here x equal minus 7, so it also implies that y equal minus 7. Now when x equal 3, so also implies that y equal 3. So then I have a stationary point of this form, minus 7, minus 7. Another point is 3, 3. So I have those points. All right. Then I can come here again. Here, I see that from here, x plus y equal minus 4. You know, we were using 1, remain 1. So it means that y equal, yes, if I take this to here, or here, I will have that 4 minus x, y equal 4 minus x. That's what it means, taking here 4 minus x. And now I'm going to substitute into 3. That's M1 that we use. So we have x squared plus 4. 4 minus x minus 21 equals 0. This gives me x squared plus 16. 4x minus 21 equals 0. So x squared minus 4x minus 5 will be equal 0. Now look at this one. This is quadratic again, which tells me that this is minus 5 plus 1 and give me minus 4. And then minus 5 times 1 give me minus 5. So the factors are plus 1 equals 0. And that means x equal 5 or x equal minus 1. So when x equal 5, if you substitute it here, when x equal 5, you will see that you have something like this. X plus y minus 4 will imply 5 plus y minus 4 equals 0. So what is that? It means that y equal minus 1. So when x equal 5, y is minus 1. We have a point there. X is 5, y is minus 1. So again, when x equal minus 1, if I put it here, I will have minus 1 plus 5 minus 4 equals 0. That implies that y equal 5. So I have another point. When x is minus 1, y is 5. So we have about 4 points. Now we want to find the maximum now and the minimum. So before we do that, we'll take partial square z over partial x square. Partial square z over partial x square is the differentiation of this with respect to x. So that will give you 6x. Then partial square z partial y square. Look at there. Partial square, partial z, partial y. So partial square z, partial y square. You see that? It's only here we find y. So we'll give us 6y. 6y. All right. So we want to test the first points. These first points. Let's test this place. Testing minus 7, these points. Let's see whether this point is maximum or minimum. We know that partial z, partial x equal partial z, partial y equals 0. That is the first condition, because if you put it there, you have 0. All right. Then partial square z. Now look at this. Partial square z, partial x squared times partial square z, partial y squared minus partial, okay, we will need here partial square z, partial x, partial y. That is, go to x, differentiate with respect to y. Look at there. If you go to x, differentiate with respect to y, we'll have 12 only there. So meaning that partial square z over partial x partial y square, will it be greater than 0? This is the condition. So let us see. This one, we have seen it that it is 6x, and x here is minus 7, times, we have another one, 6y. So that will give us 6 times 7, no, 6 times minus 7, minus 7. 6 times minus 7, minus 12 square. Okay, so we want to see whether it's greater than 0. And then, if it is greater than 0, then we will now decide whether it is maximum or minimum. Okay, let us do this. 6 times minus 7 give us minus 42. So this is also minus 42. If you times the 2, 42 times 42, give us 1764. Now this is 144. So 1764 minus 144 will give us 1620, and it is greater than 0, it's positive. So since this one is positive, the point that we are using is minus minus, that is negative negative. It means that z equal f of xy is maximum at these points, at minus 7 and minus 7. So I'd like you to carry out the other test for the other 3 points. See, this one is 3, 3. What you do now is you just carry 3 and 3. Put 6 and put 3 in the place of x, times 6 again, put 3 in the place of y. Then 6 times 3 will be 18. 6 times 3, 18. Then you say 18 times 18, give you a value. Then put 12 square, minus 18 times 18 from 144, and see whether it's greater than 0. If it is greater than 0, then that point, 3, 3, will be minimum. How? Because it is positive, positive. So the same thing will happen to these points. Of course, these points, one is negative. So, but if you put it here and also evaluate it, if it is less than 0, then it is a saddle point. It's not maximum or minimum. It's a saddle point. Provided here is less than 0, it's a saddle point. But if here is greater than 0, it means there is maximum or minimum. Then for you to determine the one that is maximum, you look at this point, the point that you are testing. Whether it is negative, negative, you know it's maximum. If it is positive, positive, you know it's minimum. So that is how it works. I'd like you to do that as an exercise. Thank you.